Unit 2, my friends, I hope this helps you. What will happen while solving an equation such that your answer is no real solution? Well, here's the deal. I'll give you a quick example. If you have x plus 1 and you say that's supposed to be equal to x, basically, logically, that can't happen. If you take a number and add 1, you can't get that same number out. Well, when you guys are solving, you'll end up subtracting x from both sides. Well, what's going to happen here is you'll have just 1 on this side, and you'll have it equal to, if you do this the right way, 0 on the other side. So really what's going to happen? You're going to get a false statement. So I'm not writing that down right now, but you'll get a false statement, which means no real solutions, okay? And then the next one, all real numbers, would be like if we started with x plus 1, but the other side this time was also x plus 1. Logically, any number you put in for x will work. So basically, when you're going through the minus x from both sides, you'll have a true statement. 1 equals 1, which means it's all real numbers. Sound good? Okay, so we got to look out for those as we go through these problems. The first one is simply the distributive property here. So I'm going to distribute the 5 to both parts. So I have, sorry, getting too fast here, 10x plus 30. And on the other side, when I distribute through, I'm going to get 30 plus 10x. Now, I'll tell you right now, as a math teacher, I already know what the answer is because I see that the exact same thing is on both sides. So basically, I could answer this, but I'm going to say, well, let's get the x's all to one side. But what we see here is the x's cancel, and here we are, just as we talked about, to a true statement. So don't answer true, don't leave this as your answer, but your answer to this one, like we've been saying, is all real numbers. Also, you could say infinite number of solutions or any number works, all that. Okay, so on this one here, I'll try to switch to red here. We've been really working with that common denominator. So this first problem, I'm going to take the first term and I'm going to multiply by 21 over 1. I'm going to take this 4 right here, which it's hard to show, but I also have to multiply that by 21 and this one by 21 over 1. Now I'm going to do this one time for you. Hopefully this will help. You need a common denominator. The 4 is really over a 1. So when I look at 3 and 7, I ask myself, does 3 go into 7? It does not. So then I double 7 to 14. Does 3 go into 14? No. So I triple 7. Does 3 go into 21? Yes, it does. There's my common denominator. All right? So now you got to really separate here and look at this part of the problem. Well, 21 over 3 really reduces to 7 over 1. So in that whole box right now, if you just look at that carefully, it says 7 times 1 over 1. There's literally just a 7 left in there. Okay? And then in the middle part here with the 4 times 21, all that says is there's an equal sign 4 times, so that's going to be our 84. And then over here, we have 21 over 7, which becomes 3 over 1. So let's slow down. There's a minus sign there. Got the minus. And then on the top, I have 2 times 3, but don't forget the x, so I have 6x sitting right there. So now I have a much easier problem to solve. I'm actually just going to subtract 84 from both sides. Okay? And I don't want you guys to be making mistakes on these calculations. Don't forget, let me show you this, how cool this is. You can literally go to your calculator when you're taking your test, and I'm just doing 7 and taking away 84. And then I'm going to get a negative answer, obviously, of 77. So what I say is I have negative 77 equals negative 6x. So now I just take my answer over here and I divide it by negative 6 because I want that x to be all by itself. So watch what happens. Divide by negative 6 and then I hit enter and look at that. It just becomes positive. It means you can't simplify that. So the answer to this problem is 77 over 6. All right, pretty cool. So now I'm going to move on to, actually, you know what? I'm going to go down because we just worked on one. This is the same type of problem. So we're going to look at this and, okay, 3, I have the 1 here, but that's really just in the numerator. So the denominator is 1. I have a 9, and I also have a 1. So you ask yourself, does 3 go into 9? Yes, it does. Okay, that means 9 is the common denominator. So I'm going to take my red here, and I'm going to multiply, again, all parts by 9. Notice how many times I'm multiplying. Okay, I show this really well on the answer key that's not the video, so look there too on my solutions, but I space it out a little bit better. But this right here, again, 9 over 3 becomes 3 over 1. So out of this right here, I'm literally left with just 6x. In the middle there, I got plus 9 times 1, so plus 9 equals, but over here the 9's literally cancel, and I have just a 10 left over. And then nothing cancels over here, so I have to do 3x times 9, which is 27x's. Okay, now to solve this, I can't combine like terms on either side right now, so I have to add 27x to both sides. Here I go. So I have 33x over here, plus 9 equals 10. But then when I subtract the 9, just solving the equation here, 33x equals 1. This is not fractions anymore. Isn't this beautiful? And then divide by the 33. So the answer that comes out is you're going to get x is equivalent to 1 over 33. All right, let's move over and do some more distributive property here. Make sure you bring the negative to both parts. This should say negative x minus 6 when you bring it to both parts equals, bring the 2 through, 2x plus 6. Okay, if you have a plus 6 here, that means you didn't distribute that negative. Make sure you do. So then I'm personally going to add the x to both sides. Here we go. So I'm going to have negative 6 equals 3x plus 6. And then be careful canceling. They don't cancel. I have to subtract 6 from both sides. And I get negative 12 equal to 3x. And then when I, whoa, what happened? Hey-o. All right, there we go. Divide by 3 to both sides. I get an x value coming out to negative 4. All right, moving along here. Hopefully these videos are being good to you. I'll probably cut it after this one and we'll do another video. All right, so these ones, do you see? We have one fraction, even the next one, fraction. So I'm personally just gonna do the cross multiplication. So that means I take 9 and I multiply by x minus 2. Look at me, the math teacher, knowing what he's doing here, putting that entire numerator in parentheses because we're gonna have to distribute in a moment. 6 times 5 is just 30, that's an easy part. But then when we bring this through, we got 9x minus 18 equals 30. Add the 18 to both sides, add 18. So that's gonna be 30 plus 18, 48. And then you divide by 9. Okay, and I wanna keep reiterating, I'm letting you use these calculators, right? So if you're like, man, I don't know if the 3 really goes into 48 or a 9 goes in, just to show you what this calculator and the magic it can create. Of course, I'd love for you to be able to simplify without this, but if you just type in 48 divided by 9 and hit enter, oh, it simplifies to 16/3. You know, and the answer that's always been for you growing up is, do we need to simplify? Yeah, you always want to simplify your answer as far as you can go. So that's 16/3 there. Okay, cross multiplication over here, watch what happens. I have 8 times x minus 2 when we go the one way, and then on the other way I have 2 times parenthesis 4x plus 3. If you forget the parentheses, we're going to be in a rough spot. So distribute through, 8x minus 16 equals 8x plus 6. When I bring that through there, get the x's to one side, so minus 8x minus 8x. They're gone here. They're gone there. What does that mean? Well, hopefully we learn that when the variables cancel and I get myself a false statement now, the answer would be no real solution. And if you're like, oh, variables canceled, no real solution, be careful. If we look back up here a little bit, the variables canceled on number 1A, but we had all real numbers as an answer because it was a true statement. Okay? So hopefully we're getting better with that.